Hi everyone. So this is Kaustubh, and I have prepared my paper on the assignment. So my project topic is predicting and reducing customer churn in fintech. So I belong to the fintech industry. So that's what I've chosen to present for today. So what I would like to do is build a ML model that can predict and subsequently reduce the amount of customer churn that happens. So to start with, the opportunity evaluation in the fintech industry, customer churn uh, is significant where subscribers discontinue their services, right? Reducing churn rates can significantly increase the revenue and reduce marketing and acquisition costs. So, and why is ML suitable for this? So, there is plenty of data available. Us being a fintech company, I've seen that we have plenty of past data, which is there of customers, how they have used our services, their demographics, what kind of issues they have faced, what kind of billing they have done in the past, and using this data, if we can, it's a high impact project. So as mentioned, even if we are able to reduce the churn by a small percentage, it could lead to big profits for the company. And feasibility, yes, predictive modeling techniques have proven effective in identifying risk customers, so making machine learning a suitable tool for this problem. Moving on to the CRISP DM business understanding. Define the problem. So, the problem statement, as I mentioned earlier, is how can we predict which customers are likely to churn and offer targeted interventions to retain them. And what is the success statement for this? Reduce churn, we'll say by 5%, which could actually lead to saving millions in revenue, right? And so, what kind of data do we have in terms of the source data? Uh, so, the customer usage patterns, the billing history, the customer support interactions, the kind of service disruptions they faced, contract and tenure details, their agreements, and all. So, these are all the past data that we have. And based on this past data, we can formulate these features, right? The number of support interactions, the number of service disruptions, and all these different factors could act as the features. And based on this, the solution validation plan. Let's move to the solution validation plan. So what we have to do is we have to define. It's a simple classification problem. The ML model will define whether the customers churn or not churn, right? Whether we can retain them or they're likely to leave, right? And how do we validate the solution? We can train the model on the historical data that we already have, and validate. Then have a test set, and then validate. We can do live A/B testing. Implement the model with a control group and a treatment group where interventions are applied based on model predictions, and then from there on we can use iterative improvement to continuously update and refine the model, right? And what kind of ML system design? So this is, as mentioned earlier, this is clearly a classification based problem. So using a decision tree based model would sort of satisfy the requirements over here. Training approach, we can employ batch training initially with periodic retraining schedules to incorporate new data and patterns, right? That's how we can look at training the model. And what kind of potential risks can come in production, right? So the training serving skew. So changes in customer behavior or service offerings over time might lead to discrepancies between training data and operational data. So that's a given. With time, customer behavior tends to change. The amount of service expectations and offerings that we have also will change. So that's one of the training serving skew that we can have latency. This needs to be real time predictions. So the model needs to be highly optimized, right? If we are able to predict, but we are able to predict on past data, and we are not able to update it on time, or the model does not predict at a real time kind of requirement. So then the model sort of does not meet its requirements. Data drift: as the fintech market evolves, customer preferences and behaviors may shift. So that is also there. So again, the ask from customers, the kind of requirements they have, their behaviors may also shift. So which necessitates regular model updates. Yes. So that's it from my side. Thank you.